At this point, we are ready to solve some limits, following theorems and learning more about how to solve a certain problem that is a limit problem. But before we do that, let's give you a little cheat sheet on easy limits that you can recognize as you are solving any equation in the future regarding limits. That will save you a lot of time, because most of those limits, if you approach them without having any knowledge about them, then you'll have a hard time applying the theorems and the equations that you learn to solve them, while in reality the solution is obvious. Somebody else already obtained that solution for us, and we save ourselves the efforts of having a long solution to that's not intended. Like if you're going to exam and you see that kind of example, the person who put the test is not expecting you to spend more than 5 seconds to solve that limit. Otherwise, if you don't know that, then you will spend maybe the whole test solving that equation, even if you are extra smart, to come up with the final solution of that limit. So the limit of a constant c as x approaches to a equals c. So the limit of a constant is a constant. So here we're talking about a limit of an exact point. So a limit of a constant c is a constant. Now the limit of 1 over x as x approaches to 0 from the left, as you see from the mark in here, equal minus infinity. In the same manner, the limit of 1 over x as x approaches to 0 from the right equals infinity. So keep those in mind, and don't ask me minus infinity, infinity, all of those sound ridiculous, having minus infinity and infinity. So it's still a debated point of having minus infinity and where does infinity stops and all those details. But get it as it is and you will be fine so far. The limit of 1 over x as x approaches to infinity equals 0. So here what happened, we applied the value of x in the equation that we see in here. So it's like you are saying 1 over x, in this case x is infinity, so 1 over infinity equals 0. And the limit of 1 over x as x approaches to minus infinity is 0 as well. So same thing here, 1 over x can be applied as 1 over minus infinity. In this case it's 0, as I mentioned, minus infinity and infinity. Anything over infinity, either minus or plus infinity, is 0. The limit of cosine x minus 1 over x equals 0, as x approaches to 0, of course. And the limit of 1 plus 1 over x all to the power x as x approaches to infinity equals e, which we know e equals 2.718. So that's it. Those are easy limits. If you wish, save them. And if you wish as well, write them down on your notes and have them handy whenever you're having an open book exam. Then you can come back to those before you start your solution and fall in the trap of solving a very complicated yet simple example. So here let's recognize the limits properties. We already introduced to one. The limit of c as x approaches to a is c, so that's 1. And if you have the limit of a function f of x to the power n as x approaches to a, that equals the limit of f of x without the power as x approaches to a all to the power of n. And that equals some constant L to the power n. So you can see what happened here. You had first the limit of the function of x to the power n, but you can change that as a representation of the limit of f of x as x approaches to a all to the power of n. That could be helpful in the future, as x approaches to a can equal the n root of the limit of f of x as x approaches to a. So in this case, all the limit encapsulated under the root instead of having only the function under the root. So that's possible, and that can be done, and it will help you approaching your solution faster than coming with the regular way. Then if you have the limit of f of x added or subtracted to g of x equals the limit of f of x added or subtracted to limit of g of x as x approaches to a. So as you observed, we had the limit as x approaches to a of f of x plus g of x. Same thing as if the limit of f of x minus g of x, you can distribute the limit over the f of x, but you keep x approaching to a, plus if you had a plus sign here, then you had it here. If you had a minus here, then you have it here as well. But you keep as x approaches to a, and you come up with your final solution. Now the limit as x approaches to a of the function f of x multiplied by g of x, then you can distribute the limit as well. So it can be limit as x approaches to a of f of x multiplied by the limit as x approaches to a of g of x. If you have the limit as here, limit as x approaches to a of f of x divided by g of x, you can distribute the limit as well. So it can be limit f of x as x approaches to a over the limit of g of x as x approaches to a, which equals some integral number over other integral number, assuming the denominator integral not equaling 0. Now if you have the limit of c of x approaches to a multiplied by f of x, so you have the c constant here multiplied by some function f of x, then you can get out that constant out of the limit. You say c multiplied by limit f of x as x approaches to a, which equals c multiplied by whatever integral you came up with after solving the limit. Now let's revise a concept that we talked about previously. The way you read this expression, you say limit f of x as x approaches to a equals some constant L. That would be your solution. So as x approaches to a, the limit of f of x equal L. So that's the way how you read it. Now there is a theorem in here. As x approaches to a, then the limit of f of x is L if the limit from the left exists and the limit from the right exists, and both limits are equal to L. So as you can see in writing here, limit f of x as x approaches to a from the right equals the limit of f of x as x approaches to a from the left equal L. Then the limit of x approaches to a on both sides, in this case, equal L. So that's something to keep in mind. I know it may sound technical so far, but we will jump into solutions and have some practical solutions and getting things ready for you. If you don't understand what's being written in here, that's totally fine. You will learn by practicing, which is one of the best ways of getting into mathematics as fast as possible. Now an example here. Use the limit properties to find limit of x squared minus 3x plus 7 as x approaches to 4. There's no plus or minus sign. Now if you want to solve it right away without the limit properties, here the one who put the question need you to apply the limit properties in order to find the solution, even though whoever solved mathematics should never be limited on the way he used in order to find the final solution, as long as your solution is identical for whatever method been recommended. So here simply you can substitute the value of x, so x approaching to 4, substitute the 4 instead of whatever you find x in the equation. In this case we have 4 squared minus 3 multiplied by 4 plus 7. Now he's using the limit properties. Since there's a plus and minus signs in here, then you can do the limit distribution over the equation while saving the plus or minus sign. So he's saying here you can distribute that into limit of x squared as x approaches to 4 and minus or plus the limit of x approaches to 4 for the minus 3x, which is right here, plus the limit of 7 as x approaches to 4, which is right here. So what you can do, he made it complicated in here. I don't know why. So here what he did at the end, he just plugged in the 4 instead of whatever x existing in the equation. Same as what we did above. But if you want to make your life easy and follow what he wants you to apply limit properties, then take the limit over here and distribute it. In this case, you have the limit as x approaches to 4 of x squared plus, okay, we have a minus sign there, but that's fine because we will put it inside the limit, plus limit of minus 3x as x approaches to 4, or you can say minus limit of 3x, you want to take care of the sign, plus the limit of number 7 as x approaches to 4. So here, as he did, plug in the 4 instead of x squared, that's 4 squared as a solution, plus here, limit of minus 3x, you plug the 4 instead of the x, that's minus 3 multiplied by 4, plus the limit of 7 here is constant, limit of constant is constant regardless of where x is approaching, plus 7, then your final solution will be 11. As simple as that. I hope that's clear for you guys. Now, the limit of rational functions, so any rational function f with a in the domain of f can equal f of a. So the limit of f of x as x approaches to a equals f of a. That's what I said at the first in here. So you have the limit x squared minus 3x plus 7 as x approaches to 4. Just plug in the 4 and you get your solution. In this case, x approaches to 4, so that equal f of 4. Then you replace wherever you find the x. Instead of that, you put a 4 and you find your solution. Another example, limit x approaches to 2, and you have this equation here. I think you know the solution by far. You just plug in the 2 to the power of 4 minus 5 by 2 cube plus 2 squared minus 7, and you come up with your final solution. And that's exactly what he did over here. So you have here 20 minus 40 equal minus 20 minus 7, that's minus 27 as your final solution. As a training for you, try to solve this equation in here, or this example. So you have a function called r of x. That's fine, you can call it f of x. I don't know. There's no need to make things complicated. You know, that's what makes math complicated. They just change the things for the student and things get more complicated. So here f of x equal x squared minus x minus 12 over x plus 3. Find limit of x of r of x, in this case f of x as we change it, as x approaches to minus 3. So you just plug in whatever f of x was in here, and the minus 3, wherever you find an x, you plug it in instead of minus 3.